First, just wanted to say thank you to Smart Geometry for having us here. We've experienced a great conference and a very welcoming conference, and it's great to see all the work that's going on. The speakers have been truly inspirational in the last two, or the two today especially. I feel truly inspired by both Ben and Sarah. I just want to start by introducing my fellow cluster champions, Elizabeth Tweedale and David Reeves. And of course, all the participants in our cluster will be coming up later, but your names will be showing up, of course, in the work. I guess just first I wanted to frame the work and sort of a bit of the underlying theme of what we're interested in and what we were interested in looking at during the workshop. And it really comes down to the moment of inception, or the sort of the moment of concept design and the way that we design in the first instance, and concerns we all shared about having that complexity, being able to work intuitively within this field of complexity, and whether or not that requires us to rethink the modes in which we make those first sketches, and which we've all talked about before, but the question is, have we looked at all the criteria that it forms part of the autonomous sort of core architectural discipline, and make sure that those people and everyone in the discourse can access computation and find a common ground. I think we have to think a little bit about what those critical elements are. What is that criteria? And I'm thinking back to what Ben said earlier, when software companies come knocking at the door and we have to define as architects what it is that's important. We want to make sure we don't forget things, because we might have a hard time getting them back into it, into the new modes of operating and design. So, these things, of course, we can all name them and we can all debate about what they are, and I think we need to have that debate, but we look at envelopes, we look at circulation, narrative, promenade, sequence, we look at spatial adjacencies and social programming, and in particular we were interested in looking at that last one on the list there, which was adjacency. And so by no means did we hope to produce work that was complete in the sense that it was dealing with the whole project with a capital P, but at least start to consider criteria that we all felt was important in that inception of the design process. So with that said, I think I just want to just start there and introduce first Elizabeth, who's been working on a software platform called RDS. It's Recursion Design, she refers to it as, and I'd like her to introduce that software, because that was one of the tools that we brought to the table, and we used it in part for the workflow. So thank you.
The Recursion Design software is an exploratory design tool for professionals in the built environment to understand spatial relationships. The first step of which allows the users to inhabit the programmatic adjacencies in a possibility space defined by relationships which they specify. The user can interact with these entities, and their relationships can be adjusted in real time. The second part of the software applies the relationships found in the dynamic model to a geometrically defined graph based on circulation speeds using a multi-agent system. So this was just one of the two tools we used, and ended up only using part of it for our workflow in the workshop. The second tool was a processing library by Dave Reeves, which he'll come up and explain a little bit of before we go into the workflow itself.
So the second platform that we were working in was a processing library which allowed us to implement a multi-agent approach to spatial organization. So within this model, programmatic elements of a brief became autonomous entities, and they begin to negotiate space in a sort of ecological way. So each of these entities or programmatic elements is able to reconfigure and redistribute themselves relative to each other to achieve certain spatial adjacencies. So in this way, spatial organization emerges from both cooperation and competition within this agent population. And this is just a quick example of a tower. The library itself was developed for application at the building scale, but for the cluster we decided to zoom out and see if we could apply sort of similar principles of adjacencies to the urban scale. So where in this case spatial relationships are being sort of pursued between elements of a brief, we were interested in pursuing adjacencies between elements of an urban fabric.
Thanks, Dave. Okay. Yeah, sorry, that was Dave's slide that he forgot to. Okay, so this is some pretty low-res, simplified diagrams that try to explain a little bit about the approach. The top left spreadsheet just defines the workflow that began in recursion design, which is essentially setting up the different entities involved, their seed positions, their weightings, whether they were fixed, and an area population that was used for the agent simulation. And then the second simplified spreadsheet below just shows setting up the relationships between these entities and the actors, the strengths, and their fitness requirements. So the diagram on the right is just demonstrating those relationships being set up. In specific, the software allows you to input in a starting point, which through a CSV or a spreadsheet-based program, and you can see in this instance it was a brief with hundreds of entities with a series of interrelationships. Yeah. So here you see the first stage, the dynamic solver, which the solution space, the idea is as it's running, you can lock in nodes and you can start to intuitively inhabit this visualization and see the types of formations and that are occurring and sort of play with the data in this network, this connectivity network, in a very abstract manner. And I think the key here is to understand that this is a solution space. It's not a geometric construct, and it's sort of almost in a way imagining an interface which we let go of the geometry for a minute and think and start to consider these other critical criteria. I'm just going to the next slide. So in order to make the workflow work, to get the workflow, we essentially took at any given point from the dynamic solver, that solution space, you could then lock the XYZ coordinates, which we then transferred into signatures as RGB values. So it just took those XYZs and expressed them as color. And what that did was allow us in the second stage to differentiate between the actual coordinate of the entity within the geometric construct and its signature as an RGB. So it's at a specific XYZ coordinate in the geometry, but it has with it a tag, and it's remembering its adjacencies from the solution space. And here it just talks about some of the behaviors of the agents, and the longer they are fixed, they release more pheromones or diffuse the graph, their surrounding graph, and this is happening in 3D voxel space. These diagrams are describing 2D space. And again, just the methodology for diffusion, for expanding and contracting. And here, I guess this is the second part. I wasn't sure if Dave wanted to speak to this. Yeah, I'll take it. Okay, so here we're in processing, and we're obviously taking so those values, those colors are basically demonstrating its the range. So one zone of color blue could actually have a series of programs in it, but in different tones of that color because they were obviously that signature. So you're seeing sort of the reorganization depending on sort of a real-time tool that allows you to then start to think about the geometric construct in the second instance after you've already considered the adjacencies in the solution, in the more of the abstract solution space of the connectivity network. Okay. Okay, so to some of the cluster work, Ludovic and Paul looked at the Stratford area. Again, thank you to ZMAP. We had a 3D map of the area, and they looked at existing, and in some ways to free up the thinking, we encouraged the participants to look to future scenarios and how they could imagine that area developing in the future. And what quickly became obvious is that, we work the way we always work. So, the diagrams, we started to draw 2D diagrams of the adjacencies and relationships that they were interested. And then they started applying weights and importances to all of these actors and entities. And then, of course, when they moved into the into the optimization, solution space, they were able to see how these static diagrams actually transformed when time was introduced into the environment. So here's a video of some of that work. So here you see I guess it speaks for itself. And so here, obviously now they're moving into the geometric construct and starting to look at how those relationships then are considered with some plot ratio and FAR requirements. And again, this is one of a few scenarios that they looked at. Now moving on to the next group, which was Singh and Akshay, they looked at, again, the same sort of, you see some of the initial diagrams. These are just some of the diagrams they were sketching. They spent a lot of time in the dynamic space, the solution space, looking at the different clusters and the connectivity network, and they had a lot of complexity in their model, and it was interesting to watch the sort of interface and interplay with this particular group, because they were really inhabiting this connectivity network and really starting to see the impacts of locking up certain reorganizations and seeing the impact on if they were to almost introduce a new actor, a new entity that had a sort of a fundamental, caused a sort of catalyst or a shift in the reorganization. So I think you'll see here at this point they start introducing a change they introduce one of these sort of catalysts, and they start to look at the reorganization of that network. And then, so you can see again they were really playing around with seating locations, and they got a lot of complexity in the actual spatial organization that I think we really encouraged to look at sort of specific moments and try to unpack what conditions were coming out of that work. And then finally, I'm going to have Dave say a few words about the last project here.
So the third group, who was Kate, Katya, and Siren, really dug into the coding side on the processing side of things, and started linking the agent behaviors with Foursquare data. So the agents that represented certain entities either grew or contracted based on their popularity at a specific point in time. We've got an animation of that. Is that a video?
Yeah, and one more.
Okay.
Yeah. And then push one more time. There we go.
So they were kind of feeding popularity data into the existing processing sketch to manipulate how the agents were sort of territorializing their environment. They also started to ask interesting questions like what happens if we treat void as an agent within the urban environment, and what are the kind of behaviors that would have relative to other agents in the system.
Okay, so that's it. That'll be it. Thought there was a couple more slides, but that's where we are. Thank you.